Hello everyone, myself Tanmay Avasthi. I am assistant professor in SIRTE college. Today we are going to discuss about the subject system engineering, and the topics which we are covering is just the introductory part of system engineering. So let's start the today's topic. So the outline of the presentation is mentioned here. First, we are covering the introductory part of system engineering, then how the system engineering is different and how it differs from traditional engineering disciplines. That is the second topic. And the third topic is the example of complex engineered systems. So let's discuss the topic one by one. So starting with the system engineering. So there are many ways in which we can define the system engineering. Here we will define the system engineering as it is the basically the function of system engineering is to guide the engineering of complex systems. The word in this definition are used in their conventional meanings. The guide, let's discuss the word one by one. So the meaning of guide, to guide is to basically to lead, manage or direct. uh, how we are going to direct it, it is basically usually it is based on the superior experience in pursuing a given course, or in another words, to the guide is to show the way. So this characterization emphasizes the process of selecting the path for others to follow, and there are many other paths from which you can choose a possible course. One of the main possible course which you can select it, that is the main primary function of system engineering. So in the next term is the engineering. As we all know what is engineering, so the engineering is defined as the application of scientific principles to practical ends, या फिर कह लें आप as to design the construction and operation of efficient and economical structure, equipment and systems. So in this definition, the term efficient and economical are particular contribution of good system engineering. Now the word system. So basically for the system, the frequently used definition of system is a set of interrelated components working together for achieving some common objective. So this definition implies a multiplicity of interacting parts that collectively perform a significant function. And the next term is the complex. So the term complex restricts this definition to a system in which the elements are diverse and have intricate relationship with one another. So that system will be called as a complex system. So if consider a home appliance like washing machine would not be considered sufficiently diverse and complex to require the system engineering, even though it have many modern automated attachments, but it has not diverse culture, so that it will not be included in the system engineering. On the other hand, the context of engineered system excludes such systems such as living organism and ecosystems. Living organism and ecosystem are also complex systems, but they does not have any engineered system. That is why it is excluded from the term complex system. So the restriction of the term system to one that is complex and engineered makes it more clearly applicable to the function of system engineering. Then come to the next part. These are all discussed just now. So from the definition, it can be seen that the system engineering differs from mechanical, electrical, and other engineering disciplines in several important ways. So we are discussing here that how system engineering is different from traditional engineering disciplines. So we'll discuss by point to point. The first point is the system engineering is focused on the system as a whole. It emphasizes its total operation. So it looks at the system from outside that is, as its interactions with the other system as well as and the environment as well as from the inside. It is concerned not only with engineering design of the system, but also with external factors which can significantly constrain the design. So some of the factors are, these includes customer needs, the system operational environment, interfacing system, then logistic support requirements, and many others like the capabilities of operating personnel, and such other factors must be correctly reflected in the system requirement and accommodated in the system design. Then the second point is, while the primary purpose of the system engineering is to guide, this does not mean that system engineers do not themselves play a key role in the system design. On the contrary, they are responsible for leading the formative stage of the new system development, which includes in the functional design of the system and reflecting the needs of the user. So important design decisions at this stage cannot be based entirely on quantitative knowledge, as they are for traditional engineering discipline, and we are discussing here the system engineering, rather than most often rely on qualitative judgment, balancing a variety of quantities and utilizing experience in a variety of disciplines, especially when dealing with the new technology. And other point is, system engineering bridges the traditional engineering disciplines. The diversity of the elements in a complex system requires different engineering disciplines to be involved in their design and development. For the system to perform correctly, each system element must function properly in combination with one or more other system elements. So the system engineer must guide and coordinate the design of each individual element that are necessary to assure that interaction between the system elements are compatible and mutually supporting. Such coordination is especially important when individual system elements are designed, tested, and supplied by different organizations. Now take to the third part of the presentation, that is the example of complex engineered system. So as we noted in the beginning, the definition of a system, which is a set of interrelated components working together as an integrated whole to achieve some common objective, would fit most familiar home appliances, just like a washing machine, consist of many important parts. Some of the parts of washing machine, which are the clothes tub, electric motor, then agitator, a pump, a timer, an inner spinning tube, and various valves, sensors, and controls. So it performs a sequence of timed operation and auxiliary functions based on a schedule and operation mode, which is basically set by the operator. Take another example, a refrigerator, a microwave oven, a dishwasher, vacuum cleaner, or any other home appliances like radio, all perform a number of useful operations in a systematic manner. But however, these appliances involve only one or maybe two engineering disciplines, and their design is based on a well-established technology. We need not to develop a new technology. So thus, that is why they fail the criteria of being complex, because their design is on well-established technology, as well as it does not involve many engineering disciplines. So they fail the criteria of being complex, and we will not consider the development of new washer or refrigerator to involve much system engineering. Although it could certainly require a high order of reliability and engineering cost, but it did not require any system engineering. Of course, home appliances increasingly include clever automatic devices that are newly available microchips, but these are usually self-contained add-ons and are not necessary to the main function of the appliance. Then since the development of new modern system is strongly driven by technological change, we shall add one more characteristic to the system require system engineering, namely that some of its key elements uses advanced technology. The characteristic of a system whose development, test and application requires the practice of system engineering are that the system that first is an engineered product and hence satisfies a specified need, then consists of diverse components that may have intricate relationship with one another, and hence it is multidisciplinary and relatively complex. And third, it uses advanced technology in the ways that are central to the performance of its primary function. So these are the 3 points for a system to be a complex system. Hence, an engineered or complex system will mean that the type that has 3 attributes, that is an engineered product, which we have discussed, contains diverse components and uses advanced technology. If the system have these 3 characteristics, then the system will be called as complex system and it will require system engineering. So at last, this is a table which shows some examples of engineered complex system. So to illustrate the types of system that fit within the definition which we have discussed, this table have given you some important modern systems along with their principal inputs and the processes involved and the outputs. Let's take one into consideration. First system is, and the systems are aligned vertically. First system is passenger aircraft. The inputs are passenger fuels, processes which takes place is combustion, thrust, lift, and we get output that the passengers will get transported. So along this, we have 4 more examples of modern harvester combined with oil refinery, then assembly plant and electric power plant, along with the inputs, process and output parameters which are self-explanatory. Thank you.